Hello once again. My name is Chapulani Chitanga. So I posted this some time ago, and I think I got it somewhere. I didn't create this diagram, but I've seen a number of diagrams like this to show you which test to use. This is statistics. For those who don't like statistics, I think we have to forgive me. I think I think we must give credit to, is it Vignesh A? I think is the person who created this, but most of the textbooks of statistics, you can see this diagram at the back of the textbook, or maybe at the front page, especially if it's a hardcover, on the covers of the page. So I'll try to explain only the common ones, okay? How do you decide? Most of the cases people collect data, they want to do a study, but they ask, but what do I do? Which one do I use? So I'm going to only explain the common ones. The others, although I know about them, but I want to make this video short, and then we can also read about them, and then we can comment. Maybe we can discuss about them, and then so I'll try to explain from each cell moving down. So you must ask yourself, is the data that I have paired or unpaired? Usually means that paired is the data from the same group of people, or is it not from the same group of people that is unpaired? For example, you use the same participants pre and post. When you collect data, you use maybe before therapy and then after therapy, and then the unpaired one can be male participants and female participants, or older participants, or younger participants. So we are talking about the data, but that data is coming from people, or maybe I'm in social sciences. That I'm saying people. If you're in hard sciences, maybe than people. But let's stick to data then. So let's start with unpaired, meaning that you have from different, let's call them group of people. Usually a study involves samples so that we can make inferences. Maybe so we want to understand the population, but use a sample. So if the data is continuous, so that is a ratio interval measurement. So before you proceed with the study, make sure that the measurement is appropriate with analysis that you intend to do. And then also what is important is how many groups do you need to compare. So if you have two groups, that's where if you test all for normality, you can go for independent t-test. So other textbooks, they write even independent measures t-test. So this way by you compare two groups, let's say younger people and older people with regard to, I don't know, whatever that we may like, maybe depression, maybe reaction to social media, something. And then if you have a problem, if there's no normal distribution, that's where you go to non-parametric test. So the equivalent of that is Mann-Whitney U test, okay? And then if you have three groups, that's where you proceed to do Anova, okay? So this Anova is independent measure Anova. So because the group, we have three different groups, we have more than two, you can read around why do we use Anova instead of a couple of t-tests. You can read around that. And then if there's no normally, the data is not normally distributed, that's where you proceed to with the non-parametric equivalent of one-way test. But scientists and researchers like we intend to focus on the parametric tests, whereby we want to able to explain the population as a sample. And then now if you see this was continuous ratio interval, but this is, what about if it's categorical data? Let's say the data is, we can order it, or it can be nominal. Let's say provinces. This one may be size me 1, 2, 3, 4, but this can be nominal, and then like kind of a name, province, type of dogs, although I don't like dogs. I'll just give you an example that is close to me. So that's where you can choose between the Mann-Whitney and chi-square. So chi-square is almost similar to correlation in regard to relationship, but because the measurement is at a categorical level, so you cannot run correlation with that. And then now here, before I forget, we have 3 groups, but here, and I forgot to say with ANOVA, you have 1 independent variable. So that's where you do one-way ANOVA. If you have 2 independent variables, you do 2-way ANOVA. If you have 3, there's a 3-way ANOVA. So it's called actually factorial ANOVA. So that's what you do there. And then now let's move up again, and then we have paired data where the same sample, same participants, and then it's continuous, 2 points. Is it normally distributed? So you run paired t-test. So this is almost similar to independent t-test. So some textbooks call it a repeated measure t-test, this one, okay? So let's focus on the as normally distributed. You can test that using a number of the Shapiro-Wilk tests. You can read around the Levin test of homogeneity of variance, especially when it comes to ANOVA. And then, so that's where you run paired. So the difference, paired t-test and independent t-test, 1-way ANOVA, 2-way ANOVA, even 3-way ANOVA, depending on the independent variables that are available there. And then also ANOVA, there's a repeated measure ANOVA whereby you use the same participants, maybe 3 conditions. So we avoid the word group here, but it's the points, they're calling points here in this diagram, but maybe conditions, maybe those who attend therapy, those who did not attend therapy, and then those that get medication with regard to whatever condition they have. And then that's what you do then. And then so if the data is not normally distributed, that's why you have a problem, and then you can choose a non-parametric equivalent of whatever that you want to do. I think, yeah, only that. So what is important, we have the same participants, or your data, is it coming from this same, maybe, I don't know, maybe it's a plant if you're in hard sciences. So if the participants, are they the same people? Are they not the same people? So that's why this is split like this. And then is it continuous? So the continuous are like, say, let's say age or weight or kilometers. So that's what to use this. And categorical, like what I said, it can be in order or it can be a name and something like that. So similar in this side. If you have any questions, you can comment at the bottom. So that we can discuss. And then, so I'm not saying I'm an expert, but I'm trying to explain, especially to those that are starting in statistics, not the experts, not those, but I'm doing this so that we can help each other and then make Africa better. Thank you so much for watching. I wish you all the best in whatever that you do. Thank you so much.